Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to discuss how to run Ancova in SPSS. Ancova stands for Analysis of Covariance. It is a statistical technique that combines elements of both analysis of variance, that is ANOVA, and regression. Ancova is used to compare whether the means of the dependent variable dV are equal across the levels of the categorical independent variable IV, while controlling the influence of the continuous covariates CV. Ancova is a combination of ANOVA and regression. Now there are some basic requirements for Ancova. Let's see those requirements. Ancova requires one independent variable on the scale of nominal or ordinal, that is discrete. One dependent variable on interval or ratio scale, that is continuous. One covariate, that is on interval or ratio scale, that is continuous. Now let's try to understand the family of ANOVA. We'll start with basic ANOVA. In basic ANOVA, one dependent variable is there, one independent variable is there, and zero covariates. So the independent variable in this case is level of education, that is postgraduate, graduate, and undergraduate. It is discrete, categorical. And the dependent variable is test score, continuous. Our objective is to study the effect of level of education on test score. This is basic ANOVA. Ancova, one dependent variable, one independent variable, and one covariate. Independent variable is level of education, dependent variable is test score, and one more variable is introduced, that is covariate, number of hours spent on study. So this we want to control it, a confounding variable. So what will be our objective? To study the effect of level of education on test score, controlling the effect of number of hours spent on study. This is Ancova. Next is one-way MANOVA. Two dependent variable, one independent variable, zero covariates. Independent variable, level of education, discrete. Dependent variable, test score, continuous. Here, the dependent variable, annual income, continuous. Two-way MANOVA. Two dependent variable, two independent variable. In the previous case, our objective will be, in this one-way MANOVA, our objective will be to study the effect of level of education on test score as well as annual income. In two-way MANOVA, our objective will be to study the effect of level of education on test score and annual income. The another independent variable is gender, to study the effect of gender on test score and annual income. So in two-way MANOVA, two dependent variable, two independent variable, and zero covariates. Mancova, one independent variable, two dependent variable, and one covariate. So dependent variable is 2, independent variable is 1, covariate 1. To study the effect of level of education on test score and annual income, controlling the effect of number of hours spent on study. Real life applications of Ancova. In medical research, Ancova is used to compare treatment outcomes among the different group of patients, defined by treatment type or dosage, while controlling for the baseline characteristics like age, initial health status, or other relevant covariates. Ancova is employed in educational research. Ancova is employed to assess the effectiveness of different teaching methods or educational interventions across diverse student groups while adjusting for variables like pre-test scores or socioeconomic status. Psychological studies. Researchers use Ancova to analyze experimental data where groups of participants receive different psychological interventions while controlling for the initial psychological traits or other relevant covariates. Market research. In consumer studies, Ancova helps to evaluate the impact of marketing strategies or product features across different consumer segments while controlling for variables like income, or prior purchasing behavior. What are covariates? Variables that are not the part of the main experimental manipulations but have influence on the dependent variable are known as covariates. and they can be included in the analysis of covariance. Covariates control for the influence of the potential confounding variables that are not the primary variables of interest, like the independent variables. By including covariates, Ancova ensures that any observed differences in the dependent variable between groups are not due to these confounding factors. Let's try to understand this concept in a layman example. Imagine you are organizing a running competition for high school students. You want to compare the performance of students from three different schools to see which school has the fastest runner. However, you realize that some students might have an advantage because they have been the part of school's running club and have trained more than others. Variables, dependent variables, running time of students, the outcome you are interested in. Independent variable, school, the factor you want to compare. Covariate, the number of weeks of prior training. This is you want to control an additional variable that might influence the outcome. Without considering the covariates, if you simply compare the running time of schools from three schools without considering prior training, you might conclude that one school is best because it has the fastest runners. However, this might be misleading because it does not account for the fact that some students had more training. With covariates, now you introduce the number of weeks of prior training as covariate in your analysis. This means you will account for the fact that some students have trained more than others, have been trained more than others when comparing the running times. So basically it's leveling the field so that we can compare appropriately. Assumptions of Ancova. The relationships between the covariates and the dependent variables should be linear. This means that the change in the dV is proportional to the change in covariates. Homogeneity of variance. The variance of the dependent variable should be equal across all groups defined by the categorical independent variable. This ensures that the error terms in the model are uniformly distributed. Independence of observations. Each observation in the dataset should be independent of the others. This means that the value of the dependent variable for one participant should not be influenced by the values of the dependent variable for the another participant. No multicollinearity. The covariates included in the model should not be highly correlated with each other. High multicollinearity can lead to unstable estimates of the regression coefficients. Measurement of covariates. The covariates should be measured accurately and reliably. Measurement errors in covariates can lead to biased estimates of their effects on the dependent variable. Now let's take the case study. Suppose the three group of students have been initially tested for their computer literacy score. This is their initial score, and their scores are recorded. They have been subjected to three different teaching methods: lecture method, computer assisted instructions, blended method, and their final scores are recorded. After 30 days of training, they are again evaluated for their computer literacy and their final scores are recorded. The data is shown below. Now, let's see how we can run Ancova in SPSS. So this is the same data set. Now we will go and analyze generalized linear model univariate. I will transfer final score, which is continuous. That is either on ratio or interval scale, transfer it in dependent variable. Method, nominal or ordinal, which is discrete. I'll transfer it in the fixed factors. Click on model. Keep the things as it is, no change. Continue. Click on contrast. No change, keep the things as it is. Click on plots. Transfer method into the horizontal axis. Add. Continue. Post hoc. Transfer method into post hoc test. Activate Tucky's test. Continue. Estimated marginal means. Method. Display means for. Compare mean effects. Activate LSD. Continue. Save. Keep the things as it is. No change. Continue. Options. Activate descriptive statistics estimates of effect size, homogeneity test, continue. Now click OK and the results are ready. So this is a descriptive statistics where you get the mean of lecture method 5, computer assisted instructions 7, blended method 11. So first we have to do the interpretation of the assumptions. We start with the first one. Levin's test of equality of error variances. Right click, copy. I'll copy this in the slide. Just see the p-value. We'll write the interpretation. As the p-value in above table are all greater than 0.05, that is 5% level of significance. So we fail to reject null hypothesis. In layman terms, we accept the null hypothesis, but we don't write it in paper. This means there is no significant difference in the variances of the final score across the three teaching methods, which are lecture, CAI, and blended method groups. So the assumption of equality of the error variances is not violated. This is desirable. This p-value should be more than 0.05. Next is test of between subjects effects. We will get this table from here. Here is it. Right click, copy. Now let's do the interpretation. Just see the p-value of method. So our interpretation is, as the p-value of method of teaching, three teaching methods are there, is 0.001, which is less than 0.05. So the results indicate that the different teaching methods have a significant effect on the student's final score in the computer literacy, explaining a substantial proportion of the variance, which is R square. So the explanatory power of this model is 68% in final scores. The model is a good fit for the data and the effect size, this partial eta square. This is proportion of variance explained, and this is the effect size, eta square, is 68% is large, suggesting that the teaching methods are an important factor in determining students' final scores. Now let's talk about the Tuckey's test. So the teaching methods are important, but which teaching method gives good result? That we can get from the pairwise comparison, which is here. Right click, copy. So it is known as Tuckey's test, post hoc test. The mean of lecture method minus mean of CI method is -2. The p-value is 0.263, which is more than 0.05. Mean of lecture method minus mean of blended method is -6. The p-value is 0.001, which is less than 0.05. So wherever the p-values are less than 0.05, the difference in the teaching method is significant. Now you compare lecture method with CI method or CI method with lecture method. The difference is only in the sign, -2 and +2. P-value will remain same. So there is no point in comparing the things again and again. Let's do the interpretation. As the p-value of pair, lecture method and blended method, this and this, the difference is -6 and p-value less than 0.05, and pair CI method and blended method, the difference is -4 and p-value less than 0.05. So we can say that the blended method significantly improves the final score compared to both the lecture method and the CI method. Now how we got this interpretation that the blended method is much better? This I can get it from the descriptive statistics. See the mean score of it. Blended method 11, CAI 7 and lecture 5. Okay. Let's proceed further. So this suggests that the blended method is the most effective teaching method among the three for improving the computer literacy scores in the study. This you can get it from the plot also, which is available here. Here is it, right click, copy. So here is a plot. Now we will introduce the initial score, the covariate. Just try to recall this example. this one, where some students had got some training, they were having the running club. So here also some of the students were good in computer initially and their scores are available. So we want to take the effect of this also. So what we will do, again we will go in SPSS. From here, click univariate. This is the initial score, which is continuous, that is on ratio or interval scale. I want to control the effect of it. So transfer it into the covariate, keep the things as it is, click OK. Now, the first thing which you should do the interpretation is the Levin's test of equality of error variances. Copy. What is the interpretation? The null hypothesis is the error variances of the dependent variable final score are equal across the different group teaching methods. In this case, see the p-value. Since the p-value is greater than the common alpha level, that is a 5% level of significance, we fail to reject the null hypothesis. This means that there is no significant evidence to suggest that the variances of the final score are different across the groups. In other words, the assumption of homogeneity of variance is met. This is desirable. Then only we can proceed further. Now the next is the test of between subjects effects. This I can get it from here. Here is it. Right click, copy. Now see the p-value of method 0.721. It is greater than 0.05. This means that the method has no effect. Quite surprising. When the covariates are introduced, the effect is now diminished. Let's do the interpretation. As the p-value in above table for method is 0.721, okay, is 0.721. Is 0.721, indicating that the teaching method does not have a significant effect on the final score when controlling for the initial score. When the initial scores were introduced as covariates in the analysis, different teaching methods did not show statistically significant effect on the final computer literacy scores. Quite surprising. Now, let's compare the partial eta square. From where I will get this? Without covariates, here is a score. And with covariates, here is a score. Here is it. Okay, let's do the comparison. Without covariate, the effect size is 0.680. With covariate, the effect size has reduced to 0.058. This means that now the effect of method on final score is just 5.8%, suggesting a very small effect size. So teaching method no longer affects the final scores. What will be the conclusion? This I will explain later on. The introduction of initial scores as covariates revealed that the teaching methods themselves were not the primary drivers of the changes in computer literacy scores. This suggests that the initial proficiency should be a key consideration in future evaluations and curriculum designs to better understand and enhance the effectiveness of various teaching methods. Now, there must be some relationship between final score and initial score. This relationship we want to study. So I'll go in graphs, legacy dialogues, and scatter plot. Simple scatter. I'll transfer final score, which is a dependent initial score, on x-axis. Click OK, double click on it, and click on the line, and you can see there is a linear relationship between initial score and final score. More the initial score, more the final score. Okay. So that's the reason initial score has been introduced as covariates in our study. So this was all about Ancova in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.